Good afternoon. Welcome to the SED MArch Juries 2026. I'm Paula Kadima, the director of SED, and we have today our keynote speaker, which is Andrew Waugh. And I just wanted to say a few words about him and his lecture before he starts the lecture. Andrew is a co-founder of Waugh Thistleton Architects, and London practice known for pioneering low-carbon design and leading the use of engineered timber. His work spans housing, cultural and mixed-use projects internationally, supported by research and advocacy focused on reducing embodied carbon and creating architecture that is thoughtful, humane, and climate-aware. His lecture today, well, he came to SED already twice, and just wanted to say that two things that attracted very much is that I really liked his ethos, the way he approached architecture, not only in regards to timber construction, but all the experiences and research that he managed to include in his office. His lecture, A Way Forward, Andrew will explore the evolution of Waugh Thistleton Architects' ethos from its early commitment to responsible design to its position today as a leader in low-carbon architecture. He will discuss how the practices focus on material intelligence, timber innovation, and occupant-centred design has shaped recent work across housing, workplaces, and cultural buildings. The work illustrates how a design philosophy grounded in environmental responsibility can deliver inventive, humane, and impactful architecture. Thank you so much, Andrew, for joining us, and please welcome.
Thank you so much. What a lovely introduction. Thank you. I'm sorry about my business partner's surname. It's really difficult to pronounce. I still struggle with it myself. So thanks for coming, everyone. So I am, as very kindly introduced, I'm Andrew Waugh from Waugh Thistleton Architects, and this is us here. This is actually a couple of years ago, but it's my current favorite Christmas card. So every year we do a Christmas card, which the rules of the Christmas card are that it must have nothing to do with Christmas, and that everybody who works in the practice should be in the Christmas card. And so, and I think every year it's really abstract, and every year it's kind of, got nothing to do with the year that's been and everything. And then I look back on them and I realize, there was one year where we made money, and the Christmas card that year is like a summer picnic, and we're all kind of like drinking champagne and stuff. Anyway, so this year was quite a tough year, as you can see. That year was a pioneering year, and our work at Waugh Thistleton, we're 29 years old now. Goodness, Anthony and I started straight from college. We really didn't have a clue what we were doing. But we had this idea. We were surrounded at the time. We were very fortunate to be surrounded by, in Shoreditch, where we both lived and where I still live, we were surrounded by artists, and they finished art school and they started painting. And so there was a kind of feeling for us that we finished architecture school, so we'll start building. And that's what we did. And we started with restaurants and cafes and bars and nightclubs, and then a house extension, and then a kitchen and a roof, and and then to little building. And now here we are 29 years later. And the work in our practice is driven by an ethos, by a sense of why we're in practice, why we're architects. And that ethos really stems from a belief that architecture should serve the society which it represents. It should serve the society of its time, and that architecture should be a contemporary and a current practice. And it is obvious to me, to us, that the primary issue of our time is the climate crisis. And, you know, when we see people talk about the climate crisis, always pie charts and graphs and Gantt charts, and what I thought I'd lay out is actually, you know, we're in the climate crisis. This is not something that's going to happen in the future. This is right now. This is Donald Trump. This is Nigel Farage. These are all the things that we were told were going to happen. This is mass migration. This is very hot summers and everything else that we know about. And so as architects, for us to deal with these things, for us to understand the impact of architecture, the impact of construction, of our cities densifying, of our population, of humanity becoming increasingly urban, then these are problems, these are issues that architects need to confront and engage in. And I actually think it's an exciting time to be an architect. It's an exciting time to engage in and be an active part and an important player in the way in which our world is going to be shaped over the next decades. And so for us, that's something that we've always really, this is not a Christmas card, by the way. So for us, this is something that we've always really been quite loud and proud about. You know, so we go on marches, we talk about climate change, we engage when we sit down with our clients, when we make competition entries. This is something that we talk about. This is something that we are not embarrassed about. This is part of our, you know, it's part of the theory of change, that you have to change the conversation, that you have to immediately engage, be loud about these things. This isn't something that we should be kind of, yeah, and actually it's quite sustainable. It's not a way in which we should be approaching this subject. And we know that, you know, we know the rules. You know, these are the rules, you know, it's about kind of building less. It's about building light. It's about changing the way in which we see success in architecture. It's about changing the way in which we frame success. So it's not about the tallest building or about the wackiest shape or the most esoteric kind of argument and position in architecture. It's actually about an architecture that makes a difference, an architecture that is part of that change and begins to think about its position in society and as a profession and as a subject and as a practice. And for us, that is a kind of, you know, that really works in our practice as three pillars. So that works as design, and we are primarily a design practice, but it also works as research, and that we are looking to constantly innovate and to invent and to understand as a practice. And so research is a really vital part of what we do. And then there's the message, you know, since we started our practice, since we started specifically, well, since we started doing buildings that people were interested in, you know, primarily in timber, we've always been completely open source with everything that we do. So we share our research, we share our drawings, we share our practice, we talk whenever anybody asks us to, we lecture and we teach. And that now is a really important part of our practice. But to begin with, I'm going to wind this back a few years. So this is a Christmas card. And this is us. I think the theme was primary school teachers. So I don't know why. I think because we were learning about timber at the time, so probably was the kind of, you know, the hidden context, the hidden text of it, subtext of it. In 2003, we built our first mass timber building. We built our first CLT building in Vauxhall. It was a tiny little kind of 40 square meter, 3-story extension to a landlocked building in South London, and had this idea of a kind of prefabricated building that we could kind of drop in, like by helicopter almost, into the backyard of this space. And we built this little building on a Saturday afternoon. 3 people built it with cordless screwdrivers, straight from the truck, straight into site, and immediately there was a structure, a building, something of kind of, you know, of strength and of beauty and of mass that was there. And the idea of this material, the idea of building like this, was something that caught on in the practice. It caught our imagination, fired our imagination. And then the more that we understood about this material, the more we understood that this could be a viable replacement for concrete and steel. that this could be something that we could think about in terms of urban housing that could replace these incredibly polluting practices. And so in 2008, after a few years of trying, in 2008, we built our first tall timber building, which is Murray Grove, 9 stories. I walk past it every Saturday morning on the way to my daughter's swimming lessons, so I can vouch for the fact that it's still there personally. And it's 29 apartments. It took 27 days to build. It took 4 people 27 days to build. Saves over 1,000 tons of carbon dioxide from building stored within the timber itself. So I'll get on to talk about trees a little bit more, but as we all know, I'm sure, that as a tree grows, as a tree flourishes, it soaks up carbon dioxide from the atmosphere. It releases oxygen back into the atmosphere for us all to breathe and stores that carbon within the trunk of the tree. So a typical European spruce will be just over half carbon, solid carbon. So they are a solid carbon store. So we take these trees and we put them in our buildings. We plant more trees in the place of the trees that we cut down, and then these trees become carbon stores. So this was the idea behind this practice. This is the idea, not only is it a carbon store, but it's a low carbon form of construction. It's a lightweight material, one that you can prefabricate incredibly accurately. So plus or minus just a couple of millimeters when you put it up. This first building, this first tall building, at the time there was really only, just kind of a standard type of CLT, 5-ply CLT like this, and we put the building together with 75 mil shelf brackets and 100 mil screws. And you can see it's very simple the way it went together. It's just kind of almost like a cardboard model, the way that the building went together. It's probably got about twice as much timber in it as it needs to have, is the truth of it. But at the time, nobody had done a building this tall, and so we threw caution at the process. But also we learned lots of other things. When you change the material that you build in, lots of other things change as well. Lots of other unforeseen things change as well. I remember vividly on the project that the electrician walking around the project on stilts. So they walk around on stilts so that they can fasten the electrics up into the ceiling. And he told me that when you're an electrician in the UK and you're an apprentice, you spend about the first 18 months of your apprenticeship hammer drilling into concrete. And after about 18 months, your shoulder joint disintegrates. And when your shoulder joint has disintegrated, then they teach you about electrics. And he was telling me this, they finished the job in half the time that they were programmed to do, because they walked around with their stilts and cordless screwdrivers. And the whole thing was done. The whole thing was finished so fast. So as I said, 27 days, 4 people built the building. Very, very quiet construction, because no hammers, no grinders, no cement mixers, no toxic dust anywhere. It was just kind of, maybe 1 or 2 splinters and a cordless screwdriver. So incredibly fast, incredibly quiet, very little waste. And when you think in London that about 60% of our waste that we send to landfill is from construction, the idea that we sent no waste from this building because of the accuracy of it to landfill is incredible. And so far fewer deliveries as well. So none of these big trucks thundering through the streets of London carrying construction components, much fewer, because it's all prefabricated and lightweight. And so following that building, we built a number of other fairly small projects. This one in 2017 was a larger scale one. It's about 22,000 square meters, 125 apartments, and 4,000 square meters of commercial. A big building for us, 10 stories tall. And you can see here, completely clad in brick, holding these balconies. And in concrete, it would have weighed 10,000 tons. There would have been over 1,000 concrete trucks, coming to site, one after another, month upon month upon month. And yet in timber it was less than 2,000 tons. And we built the entire structure in 5 months. In fact, you can see how fast it was, because by the time the train's gone past, the building's finished. And we don't only build in timber, we also look to other low carbon materials, other bio-based materials. This is a project that we did in 2017 as well, which is a cemetery for the Jewish Orthodox community in North London. And this cemetery is made completely from rammed earth. So you can see part of the whole kind of Jewish burial process is very much engaged with the soil of the site. You know, when you lay a coffin in the ground, which is part of the service, the relatives or the loved ones of that family, of that person who's deceased, will actually pick up soil in their hands or with a spade and soil and kind of lay soil back on top of the coffin. So the idea that we produced a set of buildings which came from the soil around them was seen to be an incredibly kind of fitting way of doing it. When I first went to the site and you saw that the site falls about 8 meters from one side to another, which was, when it was planted with cabbages, was absolutely not a problem at all. But as soon as you fill the whole site or potential of filling the whole site with dead bodies, then that water runoff becomes a lot more important. And so we had to move a lot of the soil from one side of the site in order to help flatten the site. And I just had this picture of this soil being trucked out, truck after truck after truck of soil. And then the idea from that emerged that we could actually build these buildings from the soil of the site. And so that there was something about the idea that you're using, a Middle Eastern technology with a British soil that seemed to be particularly fitting for this community, that this relationship that there was through the process with the soil, with the earth as well, was incredibly important. And so you can see here that the buildings seem to almost emerge, from the soil around them. And then each one of these, each one of the panels in the wall, each one of the casting panels here, is that, they're all exactly the same. And the process for making each one of those is exactly the same. And yet each one of them is completely different. And the idea that when you stand in a funeral hall, when you're at somebody's funeral, I think that most of us have at least two emotions. And one of them, is obviously sorrow and loss for the person, grief for the person that's departed, but also there's a feeling about our own mortality. And as we stand there and we stare at the building around us, you realize that actually, as the architect of one of those buildings, that every gesture that you make, every decision that you make about that building becomes incredibly important. It becomes something that will be studied by people and thought and considered by people. So the idea that you're serving specifically a community that comes, quite a homogenous community that comes from, one area of London, probably went to, a few of the same schools. There's kind of like a very similar kind of molding process went into each one of those people. And yet they're each individuals and each completely different from each other. So the idea that we applied the same idea to the floor, they're all encaustic tiles. We applied the same to the lighting, which is all hand-blown glass lights. And then the idea that you have this kind of natural material throughout. So we have a timber ceiling, so you can see the timber in the soffit. We have timber benches that surround the area for the outside wall for the elderly to sit on. And that, so that you get that kind of feeling of material, of warmth, of difference, of patina throughout the building. You can see that now. There is what it looks like now. And so in 2018, we did this project with Vitsu, who are a shelving manufacturer. This is in Leamington Spa, just in the Midlands. And the brief for this factory was really challenging. The idea was that, I don't know if you're familiar, so this is a shelving system designed by Dieter Rams. And the idea of the shelving is that it's a component system. You have two parallel rails, and within those rails you can fit different components. So shelves, cupboards, drawers, and that you can take them away when you move house. You can reconfigure that shelving as your life changes. And so the idea is that this is a sustainable, this is a long-lasting, repairable, replaceable, reusable piece of furniture that you live with. And the idea was that this building would have some of those properties, would have some of those that kind of character would be taken through to the construction. And so we designed with Vitsu this frame system that you can see in the left-hand side of the image, and that frame is made from LVL. So rather than the CLT, the cross-laminated timber that we were working with on previous projects, which is made from softwood, this is LVL, which is made from a veneer, so like plywood. And this is made from hardwood, so this is beech, which is the second most farmed tree in Europe, previously planted for furniture and now not used that much for furniture. And so this is a product from that, which is incredibly hard, incredibly tough under compression, about 2.5 times stronger than concrete under compression. So a very strong material that can span long distances as well. So this frame is held in place by the outside wall, by the CLT that surrounds the building. So we have this kind of exoskeleton, if you like, of this hard shell that surrounds this frame that holds it up. So when you're working with a timber building, when you design in concrete, a concrete building is all about holding a heavy thing up in the air. And a timber building is really very different because a timber structure weighs about 20% of a concrete structure. So when you're designing a timber structure, you're not thinking so much about how you hold it up in the air, but more about the lateral forces against it. So what we did with this lightweight frame is then we braced that with this external shell. And you can see the light coming in from the north lip windows there. You can see inside here the exposed timber in the building and the natural daylight coming through the windows, which just creates this incredibly rich and beautiful space. And I think from this building, not only was there this, understanding or evolution of this notion of the component-based system of design, but also an understanding that natural materials, that natural light coming into a building produce a really very different type of architecture, a very different type of space. And we took those ideas and that kind of notion and really employed those in this building, the black and white building in Shoreditch, which is an office building which we completed in 2022. It's an office building designed specifically for co-working, so for the office group, so like a kind of WeWork, but much more beautiful. And the entire building from the ground floor slab up is made of timber. So timber beams and columns, timber floor slabs, walls, lift shafts, staircase, core, everything in the building made of timber, and all visible. And it was a tough construction. We filled out the whole site, so we couldn't build really from either side. So the truck arrived on the pavement outside, and the crane at the back of the site lifted the pieces of timber onto the site. Each piece of timber arrived with a barcode on it, and we had a person on site with a barcode reader who would go on to, that would kind of like be read on the 3D model on an iPad and then put into place. And so a very fast, very efficient process. In fact, the entire building, the length of the site has about a 15 millimeter tolerance, and across the site about 10 millimeters. So you're working with something incredibly accurate, incredibly precise, measured, intentional process, which is so different from the kind of concrete plastic architecture that we were used to doing before. So you can see, again, we've got this LVL frame, and we love LVL because, it's so strong, it looks gorgeous as well. It's so strong, but also if you imagine when you take a tree trunk, when you cut square things from that tree trunk, you lose a lot of the tree. So you actually use probably about 60% of the tree. But when you have LVL, you take that trunk, you put the trunk against a spiralizer, you spin the trunk really fast, and you get 90% of the tree. coming out as a veneer. Then you chop the veneer up and stack it up, and that's your column. So there's a real kind of beauty to that as well, that we're really utilizing the material incredibly carefully. And with this building, we took that same kind of idea of lateral bracing, but rather than having that kind of hard external shell, what we did is, instead of putting the floor slabs on top of the columns, we laid the floor slabs within the columns, within the beams, rather, so that the floor slabs themselves give the lateral bracing to the building. So by doing that, we were able to use much more simple connections. We were able to build a building far lighter and with less timber. So we used about 25% less timber by doing that. As you can see, the building going up here, and then this is the external, the curtain walling going on, again in timber and glulam. And so, you know, on site, we were on site for above ground for 14 weeks, 6 people on site, 893 pieces of timber, each one carefully catalogued and put into place. And you know, before we started the project, we sat down with the site managers, with all the people that hadn't worked in timber before, and we sat down with them and talked about why we wanted to build this building like this, why we wanted to build it out of timber, what the differences were. And the kind of conversation that we started in those first meetings went all the way through our time on site. And the enthusiasm, the precision, the care and attention that was put on the site by those contractors, by the people building that building, was incredible. So you can see here one of the beams going in with the indentation at the top where the floor slab sits in. And so you can see again with the plan, where the core is in the middle of the building, that the way in which this kind of lateral stability works is for all the floor slabs to track into the central core. That core rises through the building and provides that kind of like that trunk-like stability through the building. So this is a building that was designed as a timber building. This is a building that was designed through components, through an understanding of what the capacity of the material was, what the advantages of the material are. And so it's designed for that. So rather than conceiving of a form, which we see so often, I think, in contemporary architecture, and then working out how to build it, this building was conceived as components which we put together to contain a space, to create a space within it. And so here you can see this very simple kind of diagram of how the building went together and how ultimately it could be taken apart. And inside are kind of lots of exposed timber, very kind of calm, open spaces. We set the staircase down into the lower ground floor from the front of the building, so the building can sit directly onto the pavement and have that kind of like, have that public presence or that civic presence onto the pavement without feeling kind of an imposing force onto the pavement and onto the street. We have opening windows throughout the building, a timber staircase that people love kind of thundering up and down. It's fantastic. And so this building is a building really of a simple set of clear design principles. It's a building that celebrates its context, but also celebrates and talks about the people that use that building, the people that inhabit it. It's an understanding of the kind of natural materials and how actually they benefit us. Thinking about the finishes of those buildings, thinking about the health, the sanity, the well-being of the people that are in that building. And that this is an architecture where we think really carefully about the design decisions that we make, both in terms of aesthetics, of architecture, of context, but also of material use, of carbon, and think really carefully about, trying to sort of, as professionals, to make those judgments about the amount of material that we're using and what we're using it for. So this produces, I think, an architecture of sufficiency, an architecture where those materials, where that architecture is put together sufficient for its purpose, and part of that purpose being the well-being of the people that live there, that work there, but also of the aesthetics and the beauty of that building. So simple finishes, reduced services, all of those things, incredibly important parts of the building. And much like some of the work that I saw today, the SED, we also employ softwares to look at the building, to help us with the design of the building. So in terms of the facade design for this building, we put the 3D model within a solar model. Ladybug. Wasn't me, obviously. So we put it within that. We tracked the solar model across the facade to maximize the amount of solar gain in the winter and minimize the solar gain in the summer. And then across that kind of heat map, we then put this solar shading across the building. So to the northwest, it runs vertically, and to the south, it runs horizontally. Across the building, we have 16 different intervals, depths, frequencies, and orientations of solar shading across the building. And so not only is the orientation of that building kind of mapped out on its facade, but also the adjacent buildings are kind of ghosted onto the facade of the building, as you can see the kind of solar shading changing across the building. And that allows us to have completely clear glass. So the glass on the outside of the building doesn't have any e-coatings baked onto it. It's not reflecting out UV. It's allowing the full spectrum of daylight to come into the space so that people working in that space are working in a far more kind of domestic feeling environment. You know, it feels much calmer. You know, you're able to sit in the desk in that office space and know what time of year it is outside, understand what time of day it is, understand what the weather is like outside. And also, this is then glass that can be recycled. So unlike all the big glass office buildings that we see across London, where the glass of those buildings is covered in these e-coatings, which can then never be recycled. And so all of that glass we look at is landfill. And so part of our process on this job, part of the project in this, was also to assess the life cycle of all the different components of the building. So this is something we do as we design, but also something that we do that when we finish the building that we draw up. So this life cycle analysis of the building gives us all the figures and the graphs and the data that one would anticipate from an LCA, but also allows us to kind of to track our projections against the kind of building in use. And so we're able to take those kind of 14,000 odd elements that put the building together, work out what the carbon burden of those were, work out how they perform operationally, and also to think about which ones will have a potential for reuse, how we can take that building to pieces in the future, reuse those components. But essentially, that's a building that has stopped. Dan? You there, Dan? Oh, there you go. I don't need you. But essentially, by replacing the concrete and steel with timber, we're able to reduce the carbon burden of construction in this building by more than half. And actually, a lot of that's just in the basement, the concrete in the basement. So the potential for doing this is massive. If you think about the figures that we were talking about at the beginning of the talk in terms of the carbon burden of construction, the fact that we can halve this with using existing technologies, existing know-hows, we can immediately halve the carbon burden of construction and design. So this building also is economically viable within the current context. So this is a building that has been commercially successful. It's fully let. It has a waiting list. It was 2/3 pre-let by the time it was finished. It was on budget. It cost the same as a concrete building, and it was on time and 4 months faster than a concrete building. So these are the kind of metrics that we take into commercial clients, and we say to them, this is a viable alternative. This is a possible alternative to the heavy carbon construction that you're engaged with at the moment. Now, we did used to do a lot of residential buildings, but post-Grenfell, because of an understanding, the tragic events there and the understanding of the combustibility of this material, a lot of nervousness around building residential buildings in timber. So in 2020, we worked with the NHBC, with UK government, with GLA and others, University College London, on producing this series of booklets, a series of guides on how we can build safely within current building regulations in the UK in timber. And again, this was kind of like, one of those things that started out as a technical exercise and yet turns into an understanding of how, when you change a construction material, the process of construction, the process of procuring a building is completely different. And we sat down with contractors, with manufacturers, and worked out the process of building these buildings, worked out the way in which these buildings could be put together with ease and with speed. And so if you follow us on Instagram, then you'll see these kind of little GIFs that pop up every now and again. So each one of the 50 details that we produce for the building has a little GIF for the contractors to show them how the whole building goes together. And the idea that these drawings that we were doing became something that were fluent, that were understandable, that took their lead really from an IKEA catalogue or from a DIY handbook. That these are drawings that are about the message of kind of clarity and simplicity and communication, not something that were designed. It's not a communication that's designed to be remote or to disenfranchise people from an understanding of how these buildings go together. And we do work with community organisations. This one in Bristol with Multimax, which is a community housing organisation, to look at a system for building low-carbon housing in Bristol, working with community and local council for a system for three-storey housing. And here's one already on site and being constructed both by contractors but also by the people that will live there. And this is this is sort of typical of the research projects that we do. We've done a few projects now for the European Union as part of the Horizon program. The one that we're working on at the moment, that I'm working on with the team at the moment particularly, is the Timber House one, which is a really broad-reaching research project, thinking about timber from first principles. So thinking about this idea of a material that humanity, that all of all living creatures have lived in symbiosis with since the dawn of time. This understanding that without trees, fish would never have crawled out of the ocean until we had trees. We would not be living on this planet as humanity, as human beings, without trees. That this relationship that we have with the tree, with bio-based materials, is something that has been with us since the dawn of time. And so we talk about things like that. We test ourselves. This is me kind of like looking at my brainwave patterns when I look at timber. And there you go. Look, hey presto, I really like timber. Apparently. But it's also this relationship that we've had with natural materials, with natural light, with having, with having plants, with having kind of nature in our buildings. This kind of move that modernism, the evolving modernism in the 1920s and 30s, this notion of science within our buildings took over, was this idea that the cleanliness, that sanitation became this vital part of architecture, became a vital kind of proponent of what we should be looking at. And so, you can see that movement, and this is something that we're kind of discussing on a daily basis in the practice at the moment, is this idea of how human shelter has moved from kind of notions of survival to notions of resilience through modernism, what Kenneth Frampton called the bleach-smelling buildings, to a new type of architecture, which is an architecture where people flourish, an architecture that's related to our planet, which is about natural materials, which is about our health and our well-being. And not just of the people that live and work and get better and are educated in those buildings, but also the people that build those buildings. The lack of responsibility of architects for the provenance of their materials or how the buildings that they design are built, I find staggering. Still, modern slavery exists in construction and in the manufacture of construction materials in far greater proportions than any other industry. And yet this is something that architects are sort of so removed from. This idea of where do our building materials come from? Who makes those materials? And how are they put together on site? What kind of life is that? And the difference between working in concrete and steel and cement and aggregates to working with timber, to working with a bio-based, natural, healthy, precise and prefabricated material. And so this is a building we've got on site at the moment in Milan. It's a very simple building. It's a building which, again, is a kind of component-based design. So it's based on this 9-meter grid where we design the beams, the columns, the facade is prefabricated, the floor slabs are prefabricated, and the whole building goes together incredibly quickly. So above ground, we're 11 months for 23,000 square meters of building. So very fast. And part of that process is to build these kind of one-on-one models to demonstrate to people how solid, how fantastic and firm and beautiful these buildings are. And in fact, you can see that's our client there, Simone. That's our insurer, Massimo. It's the guy here from Milan City Council. Funnily enough, this is our engineer. I think he might think he's holding it up. We developed this prefabricated floor system where we used a GGBS concrete in order to maintain a kind of a very steady floor for a life sciences project and as an acoustic and fire barrier between the floors of this building. And so these are prefabricated on site, 9 meters long by 1.5 meters wide, and lifted up and placed into position. So a very, very fast, effective, and efficient method of construction. You can see here on site a few months ago, in October last year, and those are the kind of that's the ceiling going in. So you can imagine this is a type of building to work in. Again, completely clear glazing all around the building. Solar shades here to the south. And as it says on our office T-shirts, we let the wood do the work. So this is about simple buildings. These are about kind of open, clear, open spaces with natural materials, natural light, and generous space. And I think that this architecture that we are focused on as a studio, this kind of ethos-based practice that we have, is about sustainability. But it's about sustainability that's not just about metrics. And so I like to encourage you all to understand that actually to build a truly sustainable building is a building that will last, a building that's adaptable, a building that works in its contexts, that works for the people that will live, that will work, that will learn, get better in that building. That this is an architecture that must actually kind of encourage people to care for it, an architecture that needs kind of that beauty, that engagement with people that are part of that building, to repair it, to kind of, that's how we create longevity in architecture. So this is not an architecture of compromise. It's not an architecture where we can't quite do the buildings that we want to do. This is an architecture of opportunity and of beauty, and this is about reframing those notions of success in architecture. And this is the number of tree seeds that grew the trees that built our first tall building. Thank you.
Thank you, Andrew, for this very wonderful and inspiring lecture. I wanted to open the floor for questions. So please, does anyone wants to start?
Hello. Thank you for the inspiring lecture.
Thank you.
I have a specific question about the joinery system of the timber buildings, especially the black and white buildings. So you said it was ultimately built to be taken apart. So I was just curious that do you take certain design decisions to make it designed for disassembly, or does that come by default with it being timber construction?
No, I think you have to have an intent for that. So there is design for disassembly. That's always conscious. So we always make sure that to take the building apart, that those things are accessible. We never glue anything. We always screw it or bolt it. All the connections for that building are encased within timber, but all the connections are accessible from the timber.
And do the client usually have the idea of it being like having potential for circular economy or reusing of materials, or do you just do it for your ethos as a firm?
I think a little of both is probably the most honest answer to that. I think that, this is a journey that we're all on, and for us as a practice, this is something that we've been doing now for 20 years, and it's an ethos and and an approach to architecture and construction that has evolved and developed over those 20 years. And so when we work with new clients, that is part of that evolution, and every new client changes the practice, helps develop our practice. So this is not it's not a static, this is an ongoing conversation. And, I'm very much of the view that architecture doesn't function without clients.
Well, I kind of have two questions. Let me start with the first one. So when you build like timber buildings, so, okay, let me take in context of London. So this is not a lot of thermal mass that you're putting in. So what do you do in terms of heat gain and heat loss? So.
Yeah, it's a funny one. It's this again is something, in Europe, especially, we come from a Greco-Roman tradition of stone and masonry and heavy thermal mass buildings. And even the software that we use, to measure energy use through the external envelope of our buildings is based on thermal resistance. And so we always struggle with that. We always we probably over-insulate the buildings that we're building, because what we find is that when we finish our projects, they always use less energy than they've been projected to use. Okay. And we know that because timber has a much softer thermal path, that it's like if you sit on a timber bench in the summer, it's not going to be hot. And if you sit on a timber bench in the winter, it's not going to be cold, because that soft thermal dynamic doesn't spike in the same way that concrete and steel do. And so the thing about a timber building, because you're not heating a structure up or cooling a structure down, you just need to keep the air flowing through. So actually, if you think about it, that is the practice of many types of architecture from other societies. I mean, Japan especially, if you think, which is largely a an architecture of a timber tradition where it gets cold, and you allow the air through, you warm the air so that, or you put a jumper on, put a sweater on.
It is quite interesting what you do as a firm in terms of your material exploration and how you kind of try and use every part of the tree with like minimal wastage. And the whole responsibility framework is really inspiring. But in terms of the rapid urbanization in such high density cities like London, where, like you mentioned, there's mass immigration and there's like growing needs for like structures being put there. I do understand that in Scandinavian countries, it's easier to adapt to a timber-based construction or like a bio-based construction. But in terms of a high-density city, do you think we'll ever reach a point where there could be a paradigm shift between, using materials that are like low carbon and like...
We don't have any choice. There's no choice. There's no choice. I mean, it's called a climate crisis because it is a crisis. This is what's facing us. This is our future. And if we don't engage with it as architects, then the industry never will. We're already one of the biggest polluting industries that there is. We need to reframe our priorities in order to really, be responsible about what it is that we do. So I think that, one of the questions that I get asked, I'm sorry if anybody's preparing to ask this question, but one of the things that I get asked is, well, how tall can you go? And I think the thing is that, I'm sure that, there are Swedish practices and American practices that are building buildings 25 stories plus. I mean, for me, that's like teaching a robot to ride a bicycle. It's like, it's kind of pointless exercise. It's not sustainable. tall buildings are not really sustainable. They don't make the cities that we really want to live in. They're not good for children or good for the elderly. You know, it's kind of like, so actually a sustainable city is not one of super tall buildings. We can build these buildings, you know, in mass timber easily to 10, 15 stories, responsibly to 10, 15 stories, where you can still open a window.
Sure.
Hi, Andrew. This is Marina. Thank you so much for your wonderful presentation. I've got a question regarding what you said, architecture being opportunity. And I wonder, I've got an example called Bidi Bidi building based in Uganda. One of the challenges that they faced would being a particular issue, being that it's a refugee camp, being that they might strip the wood to use as fuel, to use it for their food, and also for basic warmth that they have. So I wonder how architecture can be sort of reframed as architecture as conscious and not ticking the boxes what's being put down as a 2030 goal, because we need to understand the socio-political and the geopolitical sort of tension between them, based materially. I wonder what your thoughts are.
Well, I mean, the thing is that, you know, it's obviously in a scenario that you describe, the problem is not that the buildings are made of timber. The problem is that the people in those buildings are destitute, you know, and don't have proper fuel. And, you know, so I think that if we don't get this right, if we don't get this architecture, if we don't arrive at an architecture that is sustainable and practical for the global south, then this is not a successful exercise. I mean, building little buildings in Shoreditch, we're just fiddling around the edges. You know, this is not what we need to be doing. What we need to understand is how we make low carbon buildings in the areas which are going to get the most population growth, which are going to require the most buildings, which are going to, you know, which are with the cities that are becoming increasingly urban. I mean, I was in Nairobi last year, and you look at Nairobi, a city, I'm going to get this wrong, but like 7 million people, it's going to be 20 million in 10 years. You know, the rate of building is just incredible. What we can do about that kind of construction in order to help reduce the carbon in those sorts of scenarios is what's really important.
Yeah, absolutely. I wonder whether the model needs to be more adaptive and not such a horizontal sort of way of, I guess, imposing what sustainability is to meet that global 2030 outcome.
No,
and
I agree.
Being able to shift that where it needs to prioritize which category is sort of, I guess, higher implementation. And that's really where my sort of concern is, that we are maybe more consumed in the idea of hitting those goals and sort of completely being blindsided by the long-term effects that it might have, just so that we might meet that 2030 goal that we've globally sort of committed to.
Yeah, that's such a great question, and it's a long conversation. I think those goals, those targets, the notions of net zero, and, you know, of course, are useful as metrics, as ambitions, as things, but actually, we're looking at a paradigm shift is what we need to be making, not aiming for 3 or 4 years' time. Useful as it might be to give ourselves targets, it has to be about a paradigm shift, has to be about rethinking the way in which we design buildings, how we value buildings, as I was saying before, and how exactly, as you say, that we can adapt that technology and that approach to many different contexts and uses. The buildings that I've shown today obviously exist in very specific kind of context and market and client demand. So, yeah, you're absolutely right, but I'll leave that to you. Okay.
Hi, Andrew. Thank you very much for your inspiring presentation today. I have a question around fire regulations in this new changing climate in the UK around fire regulations. Have you experienced issues with planners or even clients when you're proposing timber construction or CLT construction in the
Absolutely.
last few years?
Yeah, all the time. And it's a major concern, especially because you have a combustible material, and so we work very closely with fire engineers. We have our fire engineers' work is peer reviewed by other fire engineers. It's something that we take incredibly seriously and that we're learning how to do. We're learning to understand. But as a material, engineered timber, these types of engineered timber have, the amount of research that's gone into how they burn, what rate they burn at. The amount of research is extensive. So we have really, we have an incredible amount of of both academic and practical kind of information to pull on. But it is a very important part of designing these buildings, for sure.
Yeah, I understand. My worry is that the planners or the clients and the insurance companies are putting up a lot of resistance because they lack this knowledge, and it's making our necessary move towards this paradigm shift you're talking about much harder in the last.
It's a challenge.
Years.
It is a challenge, and but the thing is I think that whenever you innovate. And you look in history, whenever invention has happened, one of the biggest barriers is always perception. It's always about changing people's mind. People are, naturally nervous, naturally cautious, especially those people whose responsibility it is to keep us safe. And so I think that necessity for us to be able to communicate about what we do, the safety of what we do, of how much we've thought about, is a really important part of our practice. And so I think that, I've actually often found those conversations really rewarding, because that close communication with people about what we do and why we want to do it, is not something that you always get in architecture.
Thank you. Maybe this will work quite well to follow up with your question, because I want to open up the conversation towards other natural materials, as no material is sustainable per se, and it depends on provenance and all sorts of things. And I feel there is probably a lot of lessons to be learned from the journey that timber and the timber industry took over the past 20 years to become a viable mass building material for certain applications. I was wondering if you have any kind of advices or ideas of how lessons could be learned from that towards stone, for example, that becomes kind of quite popular lately, or mineral-based materials.
Yeah, and we, the reason why I showed the rammed earth building today was to demonstrate that we're always looking at other forms of building, looking at other bio-based materials, looking at opportunities to use hemp or straw-based materials, and as you say, different uses, different buildings suit different types of materials. We have a stone building on site at the moment in Maidenhead, in just west of London near Heathrow, and so looking at the opportunities that those other materials provide, I think, is really important. But when such an immense proportion of our landmass is covered in trees, when there is that relationship that we have with trees, when there is the opportunity of an existing material, an existing technology, which is certified, which is available, which is understood, then I think that, for us, that it is the most obviously viable alternative to concrete and steel. So that's why I guess that we kind of champion it so much. But we do look at other things as well.
Hello. Hi, Andrew. Thank you so much for the presentation. Can you talk us about the material source regarding the timber, soft timber, hardwood, and please.
Yeah, so most of the timber that we use in the UK comes from Germany, Austria, sometimes Sweden, Spain, France. We do have trees, obviously, in the UK. We have trees in England, Scotland particularly. But the majority of the Scottish forestry industry is based around Inverness. Inverness, it's a longer drive to Inverness than it is to Salzburg, where the timber comes from in Austria. And I'm as Austrian as I am Scottish. Do you know what I mean? I don't really, for me, those kind of like the notion of kind of local as a material is not a national issue. So pulling those materials from sustainably managed forests, forests that have been managed for generations in order to be cut down, this is a crop. This is a crop that certainly supplies habitat and environment to other species, but it is a crop, and it's a crop that we use like we use corn or any other. So how we grow these trees, where we grow these trees from, the provenance of the building materials that we use, I think is a really important aspect and responsibility of architects to understand. So we do go to sawmills, we do go to the forest, we are in contact with foresters in Scotland and Wales and England, but also in Austria and France and Sweden.
Thank you.
Pleasure.
Hi, Andrew. One question as well. Thank you very much. It was very beautiful project, and it was nice to see not only the final product but like the evolution. I wanted to ask you a question about. It seems like the project we see here, it's very radical in the approach. It's very strong. When you get to the Milan one, it seems like there was a little bit of compromise. So if you can tell us a little bit more about the difference you've found in designing in timber in different places.
Yeah.
And why as well you found those.
Well, this is my house. So it's
radical.
So I was the client. So it's not just my house, obviously. It's not, so I bought, with two friends, we bought this little piece of land here. I didn't show this today, I don't know. Anyway, we bought this little piece of land here. We sold our flats and, I sold my car and one of my children, and we bought this site here. And then we got planning consent. We sold off the ground floor. We rent this floor to one of my friend's dads, and this is a photographic studio now here. And then there are 3 flats in a row, 3 double height flats in a row there. And so we were able to, in this building, certainly not compromise. Although, the compromise that we had with this building was that, we only had a very small amount of money to build with. So that was a condition on itself. The one in Italy, in Italy you have to have a concrete core. That's the building regulations. You have stricter building regulations about acoustic separation in Italy in offices than we do in the UK with homes. The acoustic separation has to be greater. So, these are challenges that you meet in each one of those scenarios. We're building in Seattle at the moment, where we have to have seismic protection for all the timber, for the timber building that we're building. So understanding those contexts, different opportunities in different contexts, different conversations, different kind of progress in terms of understanding of what these buildings can do. And, in the UK, we've been building mass timber buildings, engineered timber buildings, since 2003. So we've been building like this for 23 years. We built tall buildings before the French did, before the Swedes did, before the Austrians did. So actually there's a know-how and an understanding about this kind of technology in the UK, which, although we don't do many of them anymore, we actually have quite a kind of mature understanding in this country about the technology and how to build like this.
Thank you.
Thank you for a wonderful talk.
Thank you.
I was interested in the process on site. And when you did the rammed earth on the site, presumably the earth was of very suitable quality to be able to do that. And I'm just wondering about different conditions, whether it's a very limited amount of site conditions, say in the UK, because...
What, for rammed earth particularly?
Well, yes, I mean, what kind of earth is suitable? Because obviously it does vary.
Has to have the right kind of clay content and the right level of clay content. And we used earth from the site. We also brought earth in from another place which had a heavier clay content. We used some stones and aggregate from the site, and we used some from elsewhere as well. And it has 2% cement in it. So it's a stabilized rammed earth. It's not just a rammed earth, because we built a test wall in rammed earth, and then it rained.
Yeah.
And we and that was the same night we got planning consent. And the next morning I went to site with the chief rabbi to show the chief rabbi our sample wall. And I got to site and it was just a lump of mud. And the chief rabbi looked at me and he was like, "It's going to be all right, isn't it?" I was like, "Not a problem at all." And then, you know what, we kind of I sat with Rosie, the engineer, and, and we were like going, what are we going to do about this? And Rosie called me up in the middle of the night and said, "I've been on YouTube. I found this guy in southwestern Australia on the Margaret River, which has the same climate as the UK, and he's been building these for decades. Let's get in touch with him." So we wrote him an email, and it happened that he was on a holiday in France. So we flew him over from France to talk to us about what he could do. And, and 6 months later, he was on site with another couple of Australians, and they bought a caravan off eBay, and they rented a couple of diggers. They went to the local job centre, hired 6 kids, and built the buildings.
Fantastic.
So it was kind of it was one of those sort of stories of necessity, because we had planning consent for rammed earth buildings and a lump of mud.
How difficult is it to get permission in this country for rammed earth?
Well, uniquely for buildings of worship, they don't have to comply to many different building regulations. So there's no kind of, so I guess because otherwise we'd be repairing churches all over the place. So, oops. So it's kind of, it was sort of uniquely suitable for a place of worship.
Nice story.
Thank you.
Maybe this is a silly question, but then in terms of a timber building, and you said that it's lightweight construction and everything, how do you solve accessibility when you go more floors? Do you still have the typical elevators that you use, or how is that? And what is the difficulty in solving such?
In going taller?
Yeah.
The main difficulties in going taller is kind of, when you build a tall building, it's like a vertical cantilever. Yeah, so the wind, so it's not about holding it up, because this is a super lightweight material. You get some compression on the timber, but really it's not about holding it up. It's just about holding it still. Yeah. So if you build it like a pyramid, then there's no problem. So it's about, with a concrete building, you can build about 5-6 times higher than the width of the building. And with a timber building, you can build about 3.5 times higher than the width of the building. Otherwise, so the tall buildings that they built in Sweden and in the US, they had to put concrete on the roof and concrete in all the floors to stop it swaying about.
Okay. Do you still have time to...
Yeah, no, I'm good.
And energy to...
Absolutely.
Hi, thank you for such an interesting talk. I really appreciate it.
Thank you.
My question was about some of your research that you did about when you were talking with the UK government about getting timber details up to the new building regulations. Mm-hmm. Does that include the high-risk building regulations?
Yeah.
Oh, it does. Amazing.
It does, yeah.
How was the process of getting that approved, and how has that impacted the low carbon?
I had hair beforehand. It was challenging. It was really difficult. It was, the thing is, like I was saying to this person before, when you're dealing with people whose career and responsibility is life safety, they're really, they hold that dear, thankfully. And so actually, to make those proofs, to get through that kind of perception that people have about timber, about combustible materials, to demonstrate the care and attention that you've taken is, it's challenging. We can prove this technology to 10 stories in the UK. So that's, we're very confident about that. Over 10 stories, you need a concrete core, you need some, there are ways of doing it. If you think about what architects have done, the kind of buildings that we've persuaded people to build over the years, buildings that look like wardrobes, a whole career spent building buildings with orange lifts. If we can do that, there's no reason why we can't do this.
And has the sort of outcome of that, has that impacted at all the low carbon nature of the timber building process? So
yeah. I mean, obviously, the more concrete that you put into the building, the less carbon that you've saved going into the building. But if you look at a typical office building, about 70% of the carbon in that building is the floor slabs. So, what we say to ourselves in the practice is like, whatever we can do, incremental benefit. It's like, if you can change out the floor slabs, then don't lose the job fighting for timber columns. Because the steel columns or the concrete columns that you might have to use will be a lot smaller because the timber's a lot lighter. And you've still got 70% saving on the carbon from, so it's about, I think the thing is about, there's an element of compromise always in the practice of architecture.
Thank you.
Okay.
Okay. One here at the end.
Hello. Hi, Andrew.
Hi.
Thank you so much for your presentation. I work for Swedish Architects, and I'm currently working on a high-risk timber building. But I have a very easy question for you. What argument did you find that is the most convincing to get clients to build in timber? Or is it that your experience of building in timber has naturally drawn clients to you who want to build in timber?
That's a good question. We don't do anything else. So if they come to us, then they know what they're going to get, I guess. So but that hasn't always been, that's been since 2016. And so we have kind of like, we have some sub-rules to that rule, like rammed earth or if it's a social housing project or, we design everything to be in timber. How we take clients with us on that journey can sometimes be about policy. It can sometimes be about aspiration or values or, the conversations that we're having at the moment about the fact that, with an office building, it's worth more money in timber than it is in concrete because people want to be in a building that looks sustainable. So we use everything that we can think of,
Comes down to the economics of it.
Often comes down to the economics. But you know what? I mean, in office buildings, that's what makes it easier because you can prove in office buildings that people will pay a little bit more rent if you spend a little bit more money. So that makes that conversation more straightforward than it does with housing. But what we need, in the UK especially, is proper government policy around sustainability that we do not have. We're one of the worst in Europe now, in the continent of Europe.
Yeah, thank you.
Okay.
Okay, one more question there.
Hiya.
Hiya.
I was just wondering, if I put my architect's hat on, I could see why you would want to stay on a traditional procurement route to kind of hold control. But if I put my contractor's hat on, I can see why design and build might be, I guess, attractive because of the kind of sharing of risk to an extent. I was just wondering what procurement routes you tend to stray more towards.
I loathe design and build.
I'm sure you do.
So, you know, it's funny because we're working in the States at the moment, and in America, if you know, they're like, what? You still do that? Why would you do that? That's such a waste of money. Such a bad practice. You know, the building that we're building in Milan, I mean, it was designed to be inexpensive, but it's 2,000 euros a square meter, finished. You know, we build in London for twice the price, and our builders aren't richer. You know, they have a better standard of living. We're just not very good at it here. You know, the whole process of procurement in the UK is fraught with kind of, you know, confrontation, and, you know, it's just really, it's very tiring.
Yeah, I agree. In which case, I guess my question is really then, how far do you stray into CDP when you are doing traditional? Or do you make a very kind of targeted attempt to bring architects that have very specialist skills in the types of kind of detailing that you do in, or have like a very targeted kind of approach?
A little of
to
both.
that?
I think a little of both. It's when you're trying to change trying to change a way of doing things that we've been really doing the same way for 100 years or so, you have to be collaborative. You know, we find it with engineers, you know, who, you know, you do a sketch and the engineer kind of goes, yeah, I'll try and make that work. You're like, no, stay here. You know, work with us, collaborate with us. And it's the same with contractors. So CDP, you know, contractor design portion is a really useful way of doing that, to work and to collaborate with the contractor. Obviously, one of the problems that we have is because of design build, not many architects know how to build things, you know? And so in the practice, it's kind of quite a long training process because it's not part of what we do anymore, and which is really frustrating. Okay, thanks.
Are there any more questions? Well, I think that's it. So thank you so much, Andrew, for answering all these practical questions, dealing with challenges in real life, also some ethical questions. So it was a wonderful lecture, and thank you very much.
Thank you.